So let's do an example for exponential distribution. On average, a certain computer part lasts 10 years. The length of time the computer part lasts is exponentially distributed. What is the mean? Well, the problem says on average a certain part lasts 10 years, so that's the mean. It says what is the standard deviation? Remember again, the mean and the standard deviation are the same thing, so it's 10. What is the decay parameter, m? So m equals 1 divided by the mean. So m equals 1 divided by 10 equals 0.10. The distribution notation is x approximates the exponential distribution with the decay parameter. So therefore, x approximates the exponential with 0.10. So on average, a certain computer part lasts 10 years. So we're going to answer the following questions using that information. A, what is the probability a computer part lasts more than 7 years? On average, how long would 5 computer parts last if they were used one after another? C, 80% of computer parts last at most how long? And then what is the probability that a computer part lasts between 9 and 11 years? So for A, what is the probability that a computer part lasts more than 7 years? Okay, remember we talked about less than and greater than, so this was a more than. So remember, when it's the probability x is greater than x, we do e raised to the negative m of x, times x. So the probability that x is greater than 7, I put e, then I do the negative, and then I do my decay parameter of 0.1, and then I multiply it by 7. So if I put this in my calculator, I get 0.4966. So the probability that a computer part lasts more than 7 years is 0.4966, or really roughly almost 50%. And that's what the graph looks at, because I'm looking here for the purple from this area to the right. Okay, on average, how long would 5 computer parts last if they were used one after each other? So remember, we knew on average one computer part lasts 10 years. So if they're going to use them one after, so computer part A, then B, then C, then D, then E. So all you're going to do is multiply the 5 computer parts times the average year, so you get 50 years. Okay. 80% of computer parts last at most how long? All right, this one's a little bit different because now instead of getting the area, I'm given the area and I have to find the exact value of how long it would last. So I'm going to convert 80% to the 80th percentile. So K equals 80th percentile. So I'm going to use the natural logarithm instead of E, which is ln. Okay, so this is what you do. So again, K is the 80th percentile. So I do K equals ln where ln times 1 minus 0.80 divided by the negative m. So again, that's what I'm doing. So I'm doing ln where 1 minus the percentile I'm looking for divided by negative 0.1, which is the negative m. So again, remember, that's the x value, and that's the 80th percentile, and I get 16.1. So that means this k right here is 16.1. That's all that means. Again, if you get confused, and I'm going to go back to it. So this is basically what it is. I'm going to write it in a different way so you can see it, okay? So it's going to be L of n minus the area, and this is your negative m, okay? Gives you the, I'm going to put value on x, axis, okay? That's what it is, okay? And that's how you get it, okay? All right, so 1D. What is the probability that a computer part lasts between 9 and 11 years? So that's what that probability looks like. Probability of 9 is less than x is less than 11. So I'm going to draw the graph, which I'll show you in just a minute. So I'm going to solve it. Remember, this is a less than, and if you go back, remember the less than. So right here, 1 minus e raised to the negative 0.1 times 11 minus 1 raised to the e minus 0.1 times 9. All right, I'm going to tell you again. Do this part first, and then subtract it from 1. Then do this part first, subtract it from 1, and then do this minus that. Do it in parts. If not, you're going to get some wonky answers. So I did for the probability x is less than 11 is 0.6671. The probability x is less than 9 is 0.5934. So that minus that gives me 0.0737. So the probability that a computer part lasts between 9 and 11 years is roughly 7%. And here is the graph. So here's 9, here's 11. I'm looking for that area. It looks a lot like what we did with the uniform, but the difference is we have a different formula and it's a different distribution.